This is our Elisa theory. We are divided it into 5 parts. Introduction, working principle of Elisa, case, advantage and disadvantage, and summary. Elisa is one of the most classical immunological experimental techniques. Its principle is based on the specific bonding of antibodies to their corresponding antigen-protein molecules. This is combined with an enzyme-linked label on the antibody. It reacts with a substrate to produce color or emits light upon stimulation. Ultimately, it enables to observation, detection, and quantification of antigen-antibody complex indirectly. Key aspects are twofold. First, the specific bonding of antigens and antibodies to form a plex. Second, the ability to label and measure the antigen-antibody complex. Elisa method was pioneered by Swiss scientists in 1971 through modifications to the Ryle method. It replaced the radioactive isotopic labels in Ryle with enzyme labels. In the same year, another research group successfully quantified human chorionic gonadotropin in urine using the EIA method with horseradish peroxidase.
Okay, the first one is direct method. Enzyme-labeled antibodies bind to the antigens, you can see here. And the second one is indirect method. The primary antibodies bind to the antigen, and the enzyme-labeled secondary antibodies bind to the primary antibody. This one. And the third one is the sandwich method. Antibodies capture antigens that bind to the primary antibodies, and the enzyme-labeled secondary antibodies bind to primary antibody. You can see here, this is the results. And first one is computation method. Enzyme-labeled antigens and the antigen compared to the bind antibody. Finally, we can detect this HRP to know the number of the antibody. And the fifth one is ELISA spots. Captured antibodies bind to the cell surface protein. Biotins labeled antibodies bind to the proteins. This is still. And this small red one is released by the cells. And finally, we detect this. And the last one is in-cell ELISA. Cells grow normally. The primary antibodies bind to the cell surface proteins, and the enzyme-labeled secondary antibodies bind to the primary antibodies. And this is the result, what I said. Okay, that's all.
So, this is our Elisa reader. Basically, how to use this reader. First, load the plate. Place the prepared microplate containing your sample into the plate holder of Elisa reader, and then set the parameters like wavelength, plate layout, and other settings required for your assay, and then start the reading. The reader will analyze the sample and display the results on the screen and export them to the connected computer. Now, we are going to look into the pros and cons of the enzyme-linked immunosorbent assay. First of all, ELISA is known for its simplicity. It does not require advanced training, and results can be obtained within just few hours. Moreover, this technique is very specific and sensitive. Because of the antigen-antibody reaction, it can detect even tiny amounts of target substance with high accuracy. Unlike some other methods, ELISA doesn't rely on radioactive substances or large amounts of harmful organic solvents, which makes it both safe and environmentally friendly. Other than that, this method is cost-effective for routine operation. This is because ELISA relies on low-cost reagents compared to other analytical methods. Another key advantage is that ELISA provides quantitative results. This allows for the determination of the exact concentration of the target substance in a sample, especially when using techniques like competitive ELISA. Finally, ELISA is highly versatile. It can be applied to various sample types such as blood, urine, and saliva, and it is widely used in diagnostics, research, and even food safety applications. Okay, now let's look at some limitations of ELISA. One of the most common challenges of ELISA is the possibility of false positives. Cross-reactivity can occur where the antibodies may bind to non-target substances, leading to the inaccurate results. Moreover, the accuracy of ELISA depends on maintaining specific conditions like pH and temperature. Without a controlled environment, the results might be not reliable. Although the overall procedure is cost-effective, if we want to obtain specific antibody means it might be costly because of the expensive culture media. Lastly, antibodies are proteins that require proper refrigerated storage and careful handling. If they degrade means the performance of the assay will be significantly compromised.
Conclusion. Applications of ELISA technology including clinical diagnostics, biomedical research, environmental monitoring, food safety control, drug discovery, forensic analysis. Core principle of ELISA based on specific antigen-antibody interactions suitable for detecting biological molecules like proteins, antigens, and antibodies. Advantages and limitations of traditional ELISA. Advantage: low cost, simple operation. Limitations: lower sensitivity, limit multiple detection, less portability. Developments in ELISA technology includes microfluidics ELISA, paper-based ELISA, and atomic ELISA. Enhanced portability, flexibility, and automation. Future directions: integration with AI and data analysis for improved accuracy. Better suitability for resource-limited settings. Expanding applications in medicine, life science, and industry.